All right, you guys, happy Thursday. Sorry again to be gone. It's not what I enjoy doing, but all right, so we are moving into a whole new unit and we're going to be solving systems of linear equations, which I know you did this last year. You solved systems of linear equations, so we're going to kind of do a repeat review. So you should have this paper in front of you. Okay, when we solve systems, we're going to have more than one line. So if I'm going to use the pencils, for example, I'm going to be graphing two lines. Okay, and I should be going into focus. And when I graph two lines, I see these boxes because I have three different things that can happen when I graph lines. I can have one solution. And what that means is if when I graph, they have to cross. And where they cross is my solution. So let's say I have two lines. You can follow me. And right here where they, right here where they cross is my solution. Okay. Or I can have two lines that never cross. Okay, if they never cross, there can't be a solution because the solution is where they cross. So an answer for no solution would be two parallel lines because they're never going to cross. Now, infinite solutions. That means if I graph them, there's a solution at every single point. So they cross at every single point. So it's the same exact line. So infinitely many solutions is just one line. So let's talk about what makes this, okay? What makes them cross? What makes them be parallel? What makes them be infinite solutions? In order to cross, which means they have one solution, they have to have different slopes. So let's just write a different slope. A different slope, and the y-intercept doesn't matter. So the characteristics would be different slope. Okay. Now, in order to have no solution, and they keep going like this, okay, what has to be true about their slopes, do you think? We've talked about this, and when we talked about our last unit about parallel lines, they have to have the same slope. So they're going to have the same slope, but different y-intercepts, because they're going to start at different points, but they're going to go up at the same amount each time. So same slope, different y-intercepts. Okay? Now, infinitely many solutions means they're going to cross at every single point, which means they're the same exact line. So they have the same slope and the same y-intercept. It's essentially the same line. So if we fill this out, if two lines are parallel, they will have no solutions. If two lines are the same, they'll have infinitely many solutions. And if two lines have different slopes, then they will have one solution. This table will be really helpful for you. All right, let's flip the page and just graph a couple. Now it says solve each system and say whether there's no solution, one solution, or infinite solution. If there's one solution, you have to tell me what that solution is. Okay, so let's graph this. These are both in, let me zoom in. These are both in slope-intercept form. So we're going to start with our y-intercept, which is 1. So put a dot at 1, and my slope is -2, which means I'm going down 2 to the right 1, down 2 to the right 1. You might want to do more than 2 points because sometimes they don't cross right away. All right, my next one, I'm going to start at -1, and my slope is down 2 to the right 1. Now, what do you notice? I have parallel lines, so my answer to this would be no solution. And honestly, you guys, yes, I want you to graph this, but if you look at the equation, look, same slope, different y-intercept. So if they have the same slope, we know they have to be parallel lines. All right, let's go over number 2. Oh, this is in standard form. So we can either put it into y equals mx plus b, or we can just use our cover-up method. So I cover up x. I'm going to get 5 for y. I cover up y. I'm going to get 10 for x. Let me graph that one first. So 10, 0, and 5, 0. And then my next one, but the thing is I might want to find my slope because it's going to be kind of hard to do that. I think I'm going to actually put this in slope-intercept form. because I need to be able to see the slopes to see if they're going to be crossing or parallel. So let's do some work over here. So I'm going to subtract x. So I have 2y equals negative x plus 10, divide by 2. So y equals negative 1/2 x plus 5. So my slopes, my y-intercept is 5, down 1, to the right 2, down 1. Oh, that says 6. Sorry, guys. 5, down 1, to the right 2, down 1, to the right 2, down 1, to the right 2, down 1. And you sometimes you have to go backwards, up 1 to the right 2 to see if they intersect. So there's that. All right, I'm going to solve my next equation. So 2x plus 2y equals 8. So subtract 2x to both sides. So I have 2y equals negative 2x plus 8. Divide everything by 2. So y equals negative 1x plus 8. So I'm at 8, and my slope is negative 1. So down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, to the right 1, down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. Look, it finally crossed right there. That's what I'm saying. Sometimes you're going to have to go like more, definitely more than 2 points. You can't just estimate. So this is one solution, but it crosses at x comes first, 6, 2. So my answer is 6, 2. Okay, so I gave you one that was parallel, and then I gave you one that's one solution. Let's do another one down here. So I'm going to graph this one first. It's already in slope-intercept form. And I'm going to put this as a fraction because it's easier for me to graph with a fraction. So I'm going to start at 2, and my slope is down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. Okay, the next one I have to put into slope-intercept form. So y equals, I'm subtracting 2x to both sides, plus 8, divide by 4, y equals negative 1/2 x, pencil keeps like breaking, plus 2. Well, look at these two equations. Starting in negative 2, it's the same line. So if it's the same line, we know it's going to be infinite solutions. Okay, infinite solutions. So I gave you an example of parallel, one that intersects. Sometimes the one that intersects are sometimes the hardest because you have to like go backwards. And if they're not intersecting, maybe you should retry to plot your points. So what I want you to do is I want you to do 6 and then 7 and 8. Okay, 6, 7, and 8. And I'm going to tell you that 8 will definitely intersect. Let me look at 7. So will 7, so make sure that you're getting those correct. So if you want to pause the video and do 6, 7, and 8, go ahead and do that. Okay, so I lied to you. 7, once I solve this, 7, you're going to have y equals 2x plus 6 and y equals 2x minus 4. So I'm going to start at 6. I'm going to go up 2 to the right 1, up 2 to the right 1. I'm going to start at negative 4. Go up 2 to the right 1, up 2 to the right 1, and what do I notice? They have the same slope, so right away I know that they're going to be no solution with parallel lines. All right, let's do 8. 8, I notice they have different slopes, so they're going to have to intersect. So I'm going to start at negative 1, go up 3, 1, 2, 3, over 1, over 1. Okay, I'm going to go the other way too, 1, 2, 3, over 1, 1, 2, 3, over 1. Okay. Next one, start at 4. My slope is down 2 to the right 1, down to the right 1. Oh, that intersected nice and easy. Okay, so there's my intersection point. It looks like it's at 1, negative 2. So my solution is 1, negative 2. All right, so let's answer these bottom questions. How can you tell if a system has no solution without graphing it? Without graphing it, they would have the same slope and different y-intercepts. Okay, and then make up your own linear system. The answer would be no solution. So go ahead and do that now. All right, now you need to grab the graphing packet that's on the counter and go ahead and get started and work with the person next to you. Once you finish that, then you can start the UFO targeting, the graphing packet as well. I will check in with you guys when I get back.